Hello and welcome to a very quick video. This video is actually Halloween special, and this circuit is a Halloween circuit. I have built this circuit for a pumpkin and I will show you what it does, or first I will explain you what it does. Here we have an electret microphone as input and it has two outputs. The first one is this loudspeaker and the second one is this lamp. And if I talk into the microphone, then my voice gets amplified on these loudspeakers, and this loudspeaker also comes into the pumpkin. So then I can speak, or the pumpkin can speak via this loudspeaker. And this lamp, the intensity of this lamp gets modulated by my voice, and this lamp is also in the pumpkin. So its intensity, its brightness gets modulated when it is talking. And here you can see the circuit I have designed for it. Basically, right here we have the microphone input. Since it's an electret microphone, it needs some biasing via this resistor. Decoupling right here. Then we have a voltage gain stage. I can set the voltage gain with this resistor and capacitor. Then we have a buffer. Here we have a potentiometer. Then we have another voltage gain stage, another buffer, and then it goes right into this capacitor and resistor configuration, which actually acts as a peak hold. After that it goes into this Darlington configuration, and then we have the lamp on the output. Basically I could have done the same with PWM, and it is much more efficient with PWM. I know that, but it's just a quick circuit and I did it that way with a big heatsink, and that's it. Then the signal branches off right here and goes into another potentiometer and into this circuit, which is a very simple amplifier. The only maybe special thing on it is that I've used a compound configuration instead of a Darlington configuration, because I have a much lower voltage drop, because in Darlington you have 1, 2, 3, 4 base emitter voltage drop, and in this configuration it's much lower because we have just this 2 transistor base emitter voltage drops, and then we have a decoupling capacitor and the loudspeaker. Okay, that's for this circuit. I can also simulate it, but I will show it you in action right now. So the first thing to note before I turn it on is that I cannot turn it to a high volume, because then I would get feedback from the loudspeaker to the microphone, because it's quite near, and afterwards in the pumpkin the distance will be much higher, so that's not a problem, but currently I cannot do it. So let's turn it on, and as you can see, maybe you can see it here, you can see it already works. My voice, or the intensity of the lamp, is modulated with my voice, and I can also adjust the modulation with this potentiometer, which I showed you. So maybe you can hear a bit of this feedback now, maybe not, but if I turn it, so now we have less modulation and now we have more modulation. And in the circuit there's also this potentiometer right here, focus on it, this potentiometer right here, which allows me offset, and I will show it you now. It's actually in the circuit, it's this one, and let's see. If I turn it, you can see I can offset the intensity, so I can adjust basically the idle intensity of the lamp. And now I show the whole thing on the oscilloscope, because no scope, no fun. I've already connected the output of the audio amplifier part to my oscilloscope, to channel 1. And here you have the oscilloscope, and you can see it visually that the audio amplifier is working fine. So you can see my voice reflected on the screen. Again, I cannot turn it louder than this, because then I will have feedback. And I can show you also another point, which basically is this point right here, with this capacitor and resistor. So I will have to reconnect the oscilloscope to this point. So first turn off the circuit and connect it to this point. Yes, and turn it on again. So, and on the oscilloscope you can see here now the with the voltage on the capacitor and how the capacitor holds the voltage for some time. And if I adjust the offset, you can see the offset is also adjustable as it should be. So yeah, so it's working perfectly fine. Okay, and this concludes this quick Halloween video. So I hope you have enjoyed it, and thanks for watching. Happy Halloween and bye!